Hello, my name is Gregory and we're going to work on some trigonometry here. And if you want to look at this problem or other problems, you go to helpyourmath.com. Okay, so the technique that we're going to use to do this is, so we have an angle, tangent of an angle that's equal to -2/5 and finishes and terminates in quadrant 2. So let's figure out where quadrant 2 is. So I'm going to draw this. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So we know that this angle right here, it terminates in quadrant 2. So it begins in, it finishes in quadrant 2. So it's somewhere over here. That's where the angle finishes, in quadrant 2. But we're going to look at the reference angle. This angle right here is known as the reference angle, the angle that gets to the x-axis. So this is my reference angle. And then we're going to create a triangle here, a right triangle. Okay. So what are we going to do here? So by the way, when it comes to these signs right here, there's a little acronym that's known as all students take calculus. What that means is that all the functions are positive here, all of them. So all of them. Over here, only the sine function, the sine angle is positive. The sine of an angle is positive. Over here, only the tangent of an angle is positive. And over here, only the cosine of an angle is positive. And that's due to reasons of where the angle ends up, in which quadrant. Alright, so we know that tangent of theta is -2/5. So we're in this quadrant here, and the reason it's negative is because, you know, we're in quadrant 2, and only the sine is positive. So that explains why this is negative. Now these numbers right here are going to help dictate to us the sides. So we know that tangent is opposite over adjacent. So this sign is, we're not going to focus on this sign right now. We're going to focus on the number. So the opposite is 2 and the adjacent is 5. Opposite is 2 and the adjacent is 5. So tangent of theta is -2/5. It's negative because it's in this region, and it's 2/5 because it's opposite over adjacent. So now we're going to use the Pythagorean theorem to find our hypotenuse. So the Pythagorean theorem says that if I have a right triangle and it's labeled A, B, and C, we have a squared plus b squared equals c squared. And in this case, we have 2 squared plus 5 squared. We need to figure out the third side, our c. So 2 squared plus 5 squared equals c squared. So 4 plus 25 equals c squared. So 29 equals c squared. So I have to take the square root of both sides. So root 29 equals c. So this is my side here. This is the length, root 29. So now I have this. So from here I can figure out the cosine. The cosine of theta, I can just do it from here, is equal to, so first let's focus on the sine. So it's only the positive is negative, only the sine function is positive in this region, but the cosine is negative. So the answer is negative. But cosine is adjacent over hypotenuse, so it's adjacent over hypotenuse. So it's 5 over root 29. And we need to rationalize this. So I'm going to take this. This is the answer right here, but I'm just going to rationalize it. So I'm going to go over here and I'm going to rationalize it. Rationalize it means I'm just going to get rid of the radical in the denominator. So it's going to be equal to -5. I don't have space, you know. I apologize for that. So it's equal to, let's make space. That's not a big deal, right? We're just going to make space. I'm going to take this triangle out. So it's equal to, it's going to be equal to -5 root 29, that's my numerator, divided by 29. That's called rationalizing the denominator. So this is my answer here, cosine of theta. All right, thank you.